नमस्कार बच्चों, मेरा नाम धन्या और हम लोग सीख रहे हैं ग्रेड 11 केमिस्ट्री का चैप्टर 12 ऑर्गेनिक केमिस्ट्री। और in today's video we will be learning about the different functional group and the nomenclature of alcohol, aldehyde and ketone. Okay, now to start with, suppose I have a IUPAC naming. In the previous videos we learned about the different rules for the IUPAC naming of different compounds and also some common names we learned. Okay, and in today's video, we will be learning about the different functional groups. Okay, so if I write the name, IUPAC name of a compound, 2-chloro, butane, 1-oic acid, and if E and O are coming near each other, we just ignore this E. Okay, now in this name, 2-chloro represent the substituent name. Substituent. It is also called as prefix. And first we always write the prefix with the position, right? Then butane is the root word. It tells us how many carbon atom is there in the longest chain. Then butane. Butane is the but is the root word, sorry. And ane means it tells us whether there is a ane is, that means whether there is a single bond. If it is ene, it will tell you that there is a double bond. Ine will tell you there is a triple bond. Okay, so in this case we have used and, so it's a single bond. Then oic acid means it tells you about the functional group that is present in position 1. Okay, so this functional group are the atoms or the group of atoms which gives specific properties to a compound. Okay, and majority of the reaction takes place at this functional group. Okay, now here to start with, IUPAC does not consider chlorine, bromine, iodine, nitro group, double bond, triple bond, etc. as functional group, although they do give specific properties to the compound, but they are considered as substituent, prefix, or they are considered as, better word is substituent. They are considered as substituent, although their presence also gives some specific properties to the compound. Okay, so they are substituent according to IUPAC. Now, today we are going to first of all learn some functional groups. Okay, different functional group. Okay, and what prefix, or sorry, what suffix we would be using for different functional group. So here we have functional group, structure, and the secondary suffix that we would be using for these functional group, for each functional group. Okay, so the first one is alcohol. Okay, when alcohol group is present, the structure we use is ROH, where R can be any alkyl group. Okay, it can be CH3, it can be C2H5, okay, etc. Okay, and when alcohol is present, we use the suffix ol, OL, ol. Okay. So these things, the suffix that you have to use and the structure you have to remember. And secondly, in grade 12 and by constant practice, you can memorize it. And also in grade 12, there is a whole lot of chapters for these organic compounds. Okay. Now, second one is aldehyde. Okay. Aldehyde is RCOH. So we write like this also, RCHO. Okay. And when aldehyde is there, we use the suffix al. Okay, we use the suffix al. So ketone, where R, as usual, it's an alkyl group. R is the alkyl group, any alkyl group. Okay. Ketone is similar to aldehyde, but a small change that is there is instead of this H, here we write R dash, where R and R dash can be same or different. So R and R dash are alkyl groups. It can be the same alkyl group or different alkyl groups. Okay. And when ketone is there, we use the suffix on. Okay. Now, here, so these aldehyde and ketone, the structure is similar. Only in aldehyde, the H is there connected to carbon, and in ketone, another alkyl group or the same alkyl group is bonded to the carbon atom. Okay. Now, something that is similar to alcohol is ether. Okay. If ether is there, it is represented by ROR. This R and R are the R and R dash are the alkyl group. Can be same alkyl group or different alkyl group. Okay. And when ether is there, we use the suffix alkoxy. Okay, so alcohol and ether, the structure is similar. Only in alcohol, this H is there, and in ether, this H is replaced by another alkyl group. Okay, where R and R dash can be the same or different alkyl group. Then aldehyde is RCHO, and in ketone, this H is represented by alkyl group. Okay, and both these alkyl groups, R and R dash, can be same or different. Okay. Now, some next one, which is very important, is amine. All these groups are important. Amine. Okay. It is represented by R and H. And it is given by, okay, here. This R is an alkyl group. Okay. Here, nitrogen is connected to one carbon atom. This alkyl group is made up of carbon atom, right? So CH3, NH2, right here. I just taken one alkyl group. So here nitrogen is connected to one carbon atom. So this is called as primary amine. This is primary amine. Primary amine. Okay. Because nitrogen is connected to one carbon atom. Okay. Now we also have secondary amine. R, N, H, R dash, where R and R dash are alkyl group. Can be same or different alkyl group. Here you can see nitrogen is connected to two different carbon. One carbon of this R alkyl group and one carbon of another or R dash alkyl group. So this is secondary amine. Okay. And here we write N alkyl alkanamine. Okay, because that carbon is connected to nitrogen. That's why N alkyl alkanamine. Okay, so you have a whole lesson on amine in grade 12. So these you will learn there more. Okay, then I also have tertiary where nitrogen is connected to three alkyl groups. So all these R or alkyl groups can be same or different. Okay, so this is tertiary amine. So only all these amines are important, and secondary and tertiary amine you will be learning mostly in grade 12. More use will come there because you have the whole lesson on amine. Okay, I hope I'm clear. Okay. Now, coming to another important group which is called as carboxylic acid. And it is written like this, RCOOH. And when carboxylic acid is there, we use the suffix oic acid. Okay. Now coming to some derivatives of carboxylic acid, which would be we would be using some of the derivatives. Okay. So these things you have to memorize, but with constant practice, and we have the lessons on carboxylic acid, alcohols, etc. in grade 12. So you would be able to make it thorough. Okay. So one derivative is acid halide. What is this acid halide? It is given by RCOX. That means this OH is replaced by a halide. And how it is formed, just to for your information. And before that, this X is any halogen. Can be chlorine, bromine, iodine, fluorine, etc. And how is it formed? You know, acid plus for example, RCOOH plus suppose HCl. Okay, and this water is removed. What do you get? You get what? RCOCl. Okay, so when acid is treated with any hydrogen halide, HX is nothing but hydrogen halide, we get the acid halide. Okay, and this is how it is formed. And what is the suffix we use? Oil halide. Okay, so this formation of the acid halide you will be learning anyway. So this just to remember, okay. Oil halide is the suffix we use. Then I have the next derivative, which is acid amide. Okay, from the name itself, amide. Okay, so when acid is treated with maybe ammonia, you get here ammonia. I'm just writing it as, okay, so just to say, I just separated the hydrogen so that I can show this, the removal of water. Water molecule is getting removed, and what is left are CO O, sorry, RCOO. What is left? NH2 is left over here. What is this? This is acid amide formed by the reaction of acid and ammonia, RCONH2. Okay, so this formation is not important now. Just these names are important. Formation anyway you will be learning. And what is the name of the suffix we use? It is amide. Okay. Then the formation of the next derivative is ester. Ester, it is formed when acid is reacting with alcohol, R-OH. Okay, you can write ROH also. It's just the alkyl group. Okay. And for just to show the removal of water, I'm just writing it in the reverse order. And it is removing a molecule of water. Okay. And what do you get? RCOOR dash. Okay. And what is this? Ester. And what is the suffix we use? Alkyl, alkanoid. This is the suffix we use. This formation of ester is not important anyway, you will be learning later. Okay, you will be learning, there is a lesson in grade 12 about this, but for now, just remember the name. Okay, and the next one is acid. So these are all derivatives of carboxylic acid. Okay, so the next derivative is acid anhydride. This is the next derivative. Unless you know these, we cannot proceed with naming of the different functional group. You have to know which suffix is used. So I'm using two acids, RCOOH, and I'm writing this another acid I have to write. I'm writing it in the reverse order, HOOCR. Okay, because I want to show the removal of water. It's easy to remember. So water molecule is removed. So I have what? R, C, double bond O, O. And then for the next group, I have R dash, okay, C, double bond O, and O. And this R and R dash are alkyl group, can be same or different, okay? And the suffix that we use is alkanoic anhydride. Okay, so this is one of the derivatives of carboxylic acid. Okay, so don't worry about the big structure or anything. As you practice, you can memorize everything. Okay, and the next one is, or the next functional group is cyanide. Okay, and cyanide, the structure is RC triple bond N. It's a triple bond here, triple bond N, and the suffix that you use is nitrile. Okay, and here that triple bond is not that clear here, so make it clear. 1, 2, 3 triple bond. Okay, now the same way, if I write it like this, R N triple bond C, this is called as isocyanide. Okay, and it is given by the suffix isonitrile. Okay, I hope the two cyanide and the isocyanide is clear, so it's simple. Now I'll give you some less popular or less common groups. Okay, so these are less common. Okay, but you have to know it, okay, in case if it comes. Okay, so it is RSH. Okay, I'll tell you a way to remember this. You know, alcohol, we did it in the beginning, right? ROH. So isn't it similar to alcohol? So this is thioalcohol. So this is called, so I'm writing it here, RSH. And just remember, this is similar to alcohol. And what is the name? It is thio. Thio because this S is there. So thioalcohol. It is similar to, the structure is similar to alcohol. And the suffix that we use is thiol. Okay. Even though it is less common, you should know it in case if it comes. Okay. Then you have, this is ether. You learned about ether just a while ago. If I write a structure similar to this, R, S, R dash, this is called as thioether because it is similar to ether. And the structure is R, S, R dash, where R and R dash are alkyl group, can be same or can be different. Okay. And what is the name? Alkyl thioalkane. Alkyl thioalkane. Okay. So these are some of the functional group, and I already told you nitro groups and these alkyl halides, although they are functional groups, but the IUPAC doesn't treat them as a functional group. They also can give specific properties to the compound, but they are treated as substituent according to IUPAC. I hope I'm clear. Okay, so these are the names of some functional groups, structures, and the suffix that we use. Okay, so based on this, I will start with alcohol, how to name the alcohol. I hope you have taken a note of this. Okay, now starting with naming the alcohol. Alcohol is, structure is OH, okay, and the suffix that we use is ol. Okay, so suppose I have, so it is ROH and OH is the structure. Now, if I have, where R can be any alkyl group. If I have CH3OH, okay, here there's only one carbon atom. So, methane, 1 all. And because O and E are coming near, so I can remove this E and methane, 1 all. And because it's 1, so you can ignore this one also, no problem. Okay. And here the rule is that there is a rule, numbering of the carbon chain is done in such a way that the functional group gets the lowest number. Functional group gets the lowest locant or lowest number. Okay. So this is a rule that you must follow. Okay. So whether there's a substituent, whether there's a triple bond, double bond, etc., but you will consider the functional group. That's what IUPAC says. So IUPAC says that we should give that carbon atom lowest number that has the functional group. But the numbering should not be from the middle also, that you must take care. But anyway, we will practice. So if I have a structure like this, CH3, CH2, OH. So definitely numbering from this carbon atom, because this has the functional group, 2. So what will be the number? Ethane, 2 all. And because O and E are coming near each other, I remove this E. Ethane, 2 all. Sorry, ethane, 1 all. The functional group is at the first position, right? So because it's the first position, you can ignore this one also, no problem. Okay. And what is the common name for this? The common name is, this is the IUPAC name. IUPAC name. What is the common name? Ethyl alcohol. Usually we call it alkyl alcohol. So that's the general name. So this is ethyl group, so ethyl alcohol. Okay. Similarly, if I have CH3, CH2, CH2, OH. Okay. So what would be the name? We will start numbering from the carbon atom that has the functional group. 1, 2, 3. So 3 carbon atoms. So propane. First carbon atom has the alcohol, ol, and I remove this E here because E and O are coming near each other. And what is the common name for this? The common name is propyl alkyl alcohol. So propyl alcohol. Okay. The same thing if I give in another way, CH3, CH, CH3, OH. Okay, what will be the IUPAC name? Definitely, I cannot start numbering from the middle like this, no. So I'll number it this way, right? I can also number it this way, no problem, 1, 2, 3. Either way, the carbon having the functional group is getting number 2 position, right? So either way you can number. Now, what is the IUPAC name? Propane, 2 all, because E and O are coming near each other. I'm removing this E. Okay. Now, what is the common name here? Common name here, the now over here, the connection is from the second carbon atom. The connection of the functional group is from the second carbon atom. So we call it as what? Isopropyl alcohol. And in the previous one, because it's a straight chain, we call it as normal propyl alcohol. Okay. Similarly, if I have 4 carbon atom, 3, 4, OH, CH, CH2, CH2. Okay. Now, coming to IUPAC name, this will be given number 1, 2, 3, 4. So I have butane, 1, all. Right? There's no double or triple bond. So butane to 1, all. Right. Now coming to the common name, normal, butyl, alcohol, because it's a straight chain. Right. The same thing if I write like this, CH3, CH, CH3, CH2, OH. And over here also you can see from the second position there is the connection. The branching is from the second position, right? So what would be first we do the IUPAC name. So functional group will get the first position, I mean the carbon connected to the functional group, 2, 3. So substituent, writing the substituent name first. What is the substituent here? 2-methyl propane. There's no triple or double bond. So propane, 1, all. This is the common name. Right. Now coming to the common name, there is no, the connection is from the, branching is from the second position. So iso will come. Yes. So iso, here we consider in common name, we consider all the carbon atoms. Okay, in IUPAC name, we consider the numbered carbon atoms. So in this case, we consider all the 4 carbon atoms. So it is, and the connection is from the second carbon atom. The branching is from the second carbon atom. So it is iso, butyl, alcohol, because there are 4 carbon atom, butyl, alcohol. Okay. Similarly, if I have this kind of a structure, CH3, COH, CH3, CH3. Okay, now here we number it. We cannot number it from here because although the carbon atom having the functional group should be given the lowest position, but we cannot now start the numbering from the middle also. 1, 2, 3. So at the second position, you have the substituent methyl group also. So what would be the name? 2-methyl propane, 2, all. Yes. Now, here, what would be the common name? Now, common name for some substances, it is very important because sometimes they might give the common name in the question paper. Okay, so it is very important that you must know the name. Now, if you see here, for the common name, if you see, the carbon is connected to 3 other carbon atoms. See, the carbon is surrounded by 3 carbon atoms, 1, 2, and 3. In such a case, when carbon atom is surrounded by 3 carbon atoms, it is called as tertiary. Okay, so we call it as tertiary, and common name, we consider all the carbon atom, 1, 2, 3, 4 carbon atoms are there. Tertiary butyl alcohol. Okay, suppose they might give you a question like, what is the IUPAC name of tertiary butyl alcohol? Okay, just in case, if you don't know how to draw, it is difficult, right? Now, similarly, another example which I would give is CH2, CH2, CH, OH, CH3. So IUPAC name, we start the numbering from here 1, 2, 3. But why not from here? We can start the numbering from here. So this is wrong numbering, please, because here methyl can be included in the straight chain, right? So methyl can be included in the straight chain like this. So we can number it 1, 2, 3, 4. We cannot miss, just for giving lowest number to this OH, we cannot just miss out the straight chain, okay? So 2, at the second position, we have what? OH group. So butane, 2, all. Okay. Now, what is the common name? For knowing the common name, here you must check the carbon that has the functional group, or this carbon is surrounded by 2 carbon atom. When it is surrounded by 2 carbon atom, we call it as secondary. So it is called as secondary butyl alcohol. So when the carbon atom is surrounded by 3 carbon atom, it is called as tertiary. And when it is surrounded by 2 carbon atom, it is called as tertiary. Okay. Now, coming to some bond line structures. So these common names, by practice, it will be fine for you. Okay. So this is bond line structure. Now over here, if you see, there is a double bond and there's a functional group. There's a double bond. Okay. Now this was discussed in the previous video also. Whenever there is a functional group, priority will be for the functional group, then for double and triple bond, and then to the number of carbon atom, or the substituent, we can say here. Okay, there can be substituents too, right? Substituent. So if the functional group is there, we will give smaller position to that, okay, and that is the priority. If functional group is not there, then we go to the triple and double bond. Okay, so numbering from here, if we number from here, this carbon will get the second position, 3, 4, 5. Functional group will be given more priority. Suppose if we number it from the other way, 1, 2, 3, 4. So the carbon atom having the functional group is getting 4th position. So this is wrong. So we will not use the red numbering. We will use the blue numbering. Because that way, the carbon atom having the functional group is getting lower position. Now coming to the name, always, if the substituent is there, first we write the name of the substituent, then root word, then whether it's having a double or triple bond, then that is the suffix, then the last is the functional group, that is the suffix. Okay, so here substituent is not there, root word. So root word is pent. After root word, we give information about the double or triple bond. So double bond is there at the 3rd position, pent, 3-ene. Then we have the functional group, 2, all. Right? The next one, if we write the structure like this, what would be the name? Okay. Coming to the numbering, there is a triple bond here, there is a functional group here. So which is more priority? The functional group is given more priority. So we start the numbering from here. 1, 2, 3, 4, 5. So we have at the 3rd position, we have 3-methyl. That's how we name it, right? First the substituent, then the root word, which is pent. At the 4th position, there is triple bond, then the functional group 1, all. I hope I'm clear, right? Now, coming to the next There's an OH, there's an OH. That means here there's a carbon atom, there's a carbon atom. Okay, so that means either way, 1 and 2. So there are 2 carbon atoms. So ethane, 1, 2, diol. Why diol? Because there are 2 OH group. Similarly, for 3 OH groups, numbering 1, 2, 3. Either way, from either side you can number, it's symmetric. So here the root word, propane, 1, 2, 3, triol, because there are 3 OH groups, right? The next one, we have a structure like this, OH. So definitely the numbering will be from here, 1, 2, 3, 4, 5, 6. This structure, it is cyclo group, right? So whenever there's a cyclo group, so we write first the substituent, then if there is any cyclo group, we write down cyclo, then root word, then we look for double and triple bond or single bond, okay, and then the functional group. Okay, so here there's no substituent, but there is a cyclo group, cyclo. Root word is hexane, 1, all. Because E and O are coming to near each other, so I'm removing this E, hexane. Okay. Now, so the root word is hex, and at the first position we have 1 all. Okay. Similarly, if I have a structure like this, OH, so the numbering will be from obviously this position 1. So numbering number 2 will be the one that has single bond or double bond. Obviously, double bond. Okay. Next preference will be the double bond. 3, 4, 5, 6. So this is cyclo. Root word is hex. At the second position, we have the double bond. Okay. 1, all. Okay. Now, coming to the next question. Suppose if I have a question like this, here there's a OH group, there's a chlorine, okay? So definitely the functional group, the carbon having the functional group will be given position 1. So this is one end of a double bond. So definitely the other end will get number 2. So you cannot proceed from here. No. You have to proceed from, if you are given number 1 position to one end of the double bond, which you would definitely give because there's a functional group over here, the other end will get number 2. Okay. So next one will be 3rd position here, 4th position here. Now, what would be the name? So at the 3rd position, the substituent will be numbered first. So at the 3rd position, I have chloro. But is the root word. Then I have double bonds at 1 and 3 position, diene. one, all. Okay. So this is how we do the naming of the alcohol.